So I know that from your linear 2, question 17 was a little bit difficult, particularly in response to the t-test. So a lot of you did get this part of the question correct with the calculations. So the answer to the t-test was 3.83. But then what was difficult was answering this question in terms of how to explain whether the null hypothesis should be accepted or rejected. So I just thought to put a little bit of an explanation in a video format for you to review. So let's just look at the wording of the question. It tells you that the critical value for t, which is t-test, at the significance level of 5% with 18 degrees of freedom is 2.10. Now, if that doesn't mean anything to you, I just want to show you what this means in terms of a table. So the p-values mean probability, and we typically see that as a decimal, but essentially that is linked to a percentage, okay? So here it was 5%, which is often the p-value, so the probability value asked in exam questions. So the p-value for 5% is 0.05. For the degrees of freedom, that means your n value, so the population number, minus 1. So the degrees of freedom will be on this side, and you then read the table accordingly. So obviously this table isn't the table for this question, but for 18 degrees of freedom, the value that was correspondent to 0.05 was a value of 2.10. Now the values on these tables, those are called critical values. And those are the values that you are going to compare your t-test to. So for example, the t-test was 3.83. The critical value is 2.10. So 3.83 is larger than 2.10. So what does that mean in terms of the null hypothesis? When our t-value is larger than the critical value, we are rejecting our null hypothesis. And what does the null hypothesis say? It says that any differences between our two populations, so NA and NB, are only due to chance. Okay, so there is no significant difference between those two populations, and any difference really is only due to chance. There's nothing else that is influencing those two groups and the differences between them. So if this value is larger than the t-value, it means that the differences between those two populations is not just due to chance. There is something else that is influencing the differences between those two populations, okay? So we would reject the null hypothesis because the t-value is greater than our critical value. So look at the mark scheme. We reject because the value of t is higher than the critical value. So the null hypothesis, which is HO, is rejected. So the difference between the means is significant. They are statistically different from each other. It's not just due to chance that those two populations are different. There is something else. There is a significant difference between the two of them. Okay? So I hope that helps, but if there's anything else, just let me know.